If I have to ask you a question, what is the most important thing or element for life on Earth or on any other planet, if there is one, for that matter? Majority of you will answer air or oxygen. Well, that's not entirely wrong, but you should also know that there are several anaerobic organisms, which means they can survive without oxygen. Hence, presence of oxygen is not a defining criteria for life. So what it is then? Well, the answer is sun. Yes, a star is the ultimate source of energy for the respective star or solar system, from microscopic to multicellular organisms. Sunlight is the only source of energy, either directly, like in case of plants, or indirectly, like in case of humans or other heterotrophs. The sun is like a father figure to the solar system. It burns so that life could flourish on planets within the habitable zone. Hello and welcome again to my channel. I am here to give you interesting insights of the cosmos, and in this video we will see how a star is born and its life journeys ahead. But before going any further into the main topic, we need to understand the type of stars based on their surface temperature and luminosity under what known as stellar classification. The stars are grouped into 7 main categories or classes, that is O, B, A, F, K, and M. In this system, the size and temperature of the star keeps on decreasing from O to M, meaning the heavier and hotter is O, and the smaller and comparatively less hot is M. Talking about luminosity, not all stars in the sky appear same. Bigger stars appear more bluer, while the smaller ones appear more reddish to yellowish. Now you must be wondering, where does our sun stand in this category? Well, our sun is a relatively small star and classed as G, with a surface temperature of about 5,800 Kelvin. You might also need to understand one more term here, that is solar mass. A solar mass is the standard unit of mass in astronomy, which is equal to 2 into the power 30 Kelvin. And this is also the mass of our sun. I will be using this term for references in this video. So let us now see how a star is born. The birth and death of a star is a cyclic process, which means a new star is born from the remnant of a dead star, an old star dead, a new star born, and the cycle continues. The process begins with massive clouds of dust and gases, mainly hydrogen and helium, coming together inside a nebula. A nebula is what remained of a star which has undergone supernova after its death. It's even worth mentioning here that hydrogen and helium were 2 of the earliest known elements formed during the event of Big Bang via a process called nucleosynthesis. These clouds of gases spreads across millions of light years and drifts freely along the galaxy for millions and even billions of years until something causes them to collapse. It can either be a collision between 2 such clouds or a shock wave from a nearby supernova. At this brief moment, the gravity gets a chance and things start coming together, collapsing under the influence of gravity. As the cloud collapses, big pieces of them keep shearing off and drifting away, each of which will be a star of its own. At this stage, these clouds containing many future stars are sometimes referred as stellar nurseries. The gravity continues to pull nearby material inward, and the conservation of momentum from each individual material inside the cloud starts the spinning process. As the gravity pulls the gas and dust together, these regions become increasingly dense and hot, eventually forming a protostar. The protostar continues pulling materials inside, and this process of accumulation can go on for as long as millions of years. As materials keeps flowing in, the gravity at the core keeps increasing and the temperature keeps rising. At this stage, when all the inflow of materials come to a halt, the protostar begins to shine as a normal star. But still, the temperature and pressure inside the core is not enough to start the nuclear fusion. Astronomers call this stage a T-Tauri star, and over the period of next 100 million years, the gravity continues to collapse the T-Tauri star until the pressure and temperature within the core reaches the point where nuclear fusion can begin. Now that we have got enough temperature and pressure inside the core of the protostar, hydrogen atoms starts to fuse, forming helium atoms and releasing a tremendous amount of energy in the process, which then triggers a nuclear chain reaction. This energy radiates outward, balancing the gravitational forces pulling the whole mass of the star towards the core. From now on, the protostar will become a main sequence star. Main sequence star is a star which actively fuses its primary fuel, that is hydrogen, into helium inside the core. A star will spend most of its life as a main sequence star, which could go on for as long as millions and billions of years, depending upon the size and mass of the star. During the whole main sequence stage, a star remains in a constant battle in order to prevent itself from collapsing within its own core. The gravity tries to collapse the star into the core, while the outward energy generated from nuclear fusion balances it. And as long as this equilibrium is maintained, a star will live. But sooner or later, a star will eventually run out of fuel. The nuclear fusion will no longer be able to balance the gravitational pull. What will be the fate of the star then? We will discuss that in our next video. Till then, may the force of universe be with you.